assume that x and y are function of t. After that, we can take derivative of y with respect to t and derivative of x with respect to t and all of this into one equation. So that's why this type of problem is called a related rates problem. Right. So since all of them are function of t, we take derivative both sides with respect to t. So first thing we do is differentiate with respect to t. So we have the left hand side and the right hand side just 7. And we differentiate with respect to t. On both sides. Right. Derivative of 7 on the right hand side is equal to 0. So that is easy. Now on the left hand side we'll split as d over dt of x squared minus d over dt of 2xy minus d over dt of y squared. As mentioned before, derivative on the right hand side, derivative of 7 with respect to t is 0. Right. Now let's focus on derivative of x squared on y squared with respect to t. So we have derivative with respect to t of something square. Whether that is x squared or y squared, it doesn't matter. I put an extra bracket here. So when we take derivative uh, of the parentheses, it's going to be 2 times the parentheses. And after that, we need the derivative of the parentheses. Where there we have x or whether we have y, it doesn't matter. We could have y. In that case, it will be y. Right. So derivative of x squared with respect to t is equal to 2x x prime or just dx over dt. Right. So for x squared, we will have derivative of x squared with respect to t is 2x, and then dx over dt. I will write that in red. Right. Derivative of y squared with respect to t will be the same thing. So it will be 2y dy over dt. Right. Now, the middle, 2xy. Notice that x is a function of t, y is a function of t. So pretty much we have a function of t times another function of t. So we have to use a product rule in the middle. Right. So I'm going to write the first term is equal to 2x. The second term is equal to y. And then derivative of the first term, derivative of 2x, or we just say d of dt of 2x. And we can take the 2 outside. We have 2 times dx over dt. Derivative of the second term is just d over dt of y, or just dy over dt. Right. And we're going to put in the product rule for the middle. Uh, just watch out for the negative sign here. Right. The product rule And so we're going to substitute that in derivative of the first will be 2 dx over dt times the second, and then plus the first term, and then derivative of the second, and then y squared will be just like x squared, will be 2y dy over dt. The right hand side is 0. Right, now let's remove the bracket and simplify it a little bit. We should have 2x. Now just write in one column, minus 2y dx dt, and then minus, distribute with the plus, negative, positive, will be negative 2x dy dt, and minus 2y dy dt. Right, so this what we have. Right, now let's go back to the original problem. We have dy over dt, x, y. We're looking for the x over dt. So let us write that out. So what we have is dy over dt equal to -1. X is 2 and y is -1. And the x over dt, we don't know that, but we're looking for it. Right. Now substitute all of these numbers into the equation. We have 2 times x is 2. The x over dt, we don't know. Let's write the x over dt because we solved for the x over dt. All right, let's try that. Minus 2y, y is -1. The x over dt, which we don't know, minus 2x, 2 times 2, dy over dt, -1, minus 2y, y is -1, dy dt, also -1. All that equal to 0. Right. Now, 2 times 2 is 4, so we have 4 dx over dt, -2 times -1, 2 dx over dt, -2 times 2 times -1, that's a plus 4, and -2 times -1 times -1, so that would be -2 equal to 0. Combine like terms, we have 6 dx over dt plus 2 equals 0. And now we just need to subtract 2 on both sides. And so we have 6 dx dt, cx over dt is -2, or dx over dt. So the x over dt is -2 over 6, is negative 1 over 3. So that's what we have for this problem.